Okay, let's find the derivative of this function. So we're going to find dy dx. Sometimes we use function notation where this would be f prime of x. Or in our case, because it's y, maybe we won't use f prime. Let's go ahead and say this is going to be the same thing as y prime. Okay, just depending on what notation you like to use. Now in this case, most of this goes back to, do we know how to rewrite the square root as an exponent? So in this case, the index on our radical is a 2, and we have an exponent of 1. So that means we can rewrite this as x raised to the 1 over 2 power. All right, from here, we can use the power rule for taking derivatives, where the exponent comes down in front, and then you want to reduce the exponent by 1. So off to the side here, we want to subtract 1 away from our exponent. So we need to kind of get a common denominator here. I'm going to rewrite the 1 as 2 over 2. And as we combine those fractions together, now that we have a common denominator, we can do 1 minus 2 for our numerator, makes negative 1 for our new numerator, keep the common denominator. So our new exponent is going to be negative 1 over 2 for our derivative. Now, if you're allowed to leave negative exponents, leave it just like that. If not, we can rewrite this, leaving the 1 up in the numerator. It already has a positive exponent. The 2 is going to be in the denominator, again, positive exponent, but we can move the x to the 1/2 power down here by making it a positive exponent. Move from numerator down to the denominator by making it a positive exponent. And another alternative, we could write this back in its square root form. Instead of x to the 1/2, the square root of x means the exact same thing. Again, that 2 and the square root of x are connected with multiplication. So I hope this helps out. Most of it really is just how comfortable you are on rewriting it so you can use the power rule. And then subtracting 1, you got to get that common denominator, but overall that's not that bad. So I hope this helps out. Good luck as you're working on derivatives.